What you're about to see will challenge everything we thought we knew about objects from beyond our solar system. Scientists just released new images of the Interstellar Visitor 3I/Atlas. And I'm not exaggerating when I say that every single astronomer who's looked at these photos has had the same reaction. This shouldn't be possible. The patterns we're seeing, the structures that are showing up in these images, they defy our current understanding of physics. And the most disturbing part? This isn't the first time we've seen it. The structure is repeating itself over and over again, with a precision that has left the scientific community speechless. Some are calling it the most important discovery in interstellar object research. Others are quietly asking questions that nobody wants to say out loud. By the end of this video, you'll understand why 3I/Atlas might be the most mysterious object ever detected entering our solar system. For those of you who might be new to this story, let me give you some quick background. 3I/Atlas was first detected in 2019 by the Atlas Survey System in Hawaii. Now, what makes this object so incredibly special is that it's an interstellar visitor. That means it didn't originate from our solar system. It came from somewhere out there in the vast darkness between the stars, traveling through space for who knows how long before entering our cosmic neighborhood. Only a handful of interstellar objects have ever been confirmed, and each one gives us a rare glimpse into what exists beyond the boundaries of our own solar system. When 3I/Atlas was first discovered, astronomers were immediately fascinated. They began tracking it, studying its trajectory, analyzing its composition, trying to understand where it came from and what it might tell us about the universe. And here's where things get really interesting. From the very beginning, this object displayed some unusual characteristics. Its brightness fluctuated in strange ways. Its trajectory didn't quite match what we'd expect from a typical comet or asteroid. There was something different about it, something that didn't fit neatly into our existing categories. Now, fast forward to the present day. New high-resolution images have just been released, captured using some of the most advanced telescopes and imaging technology available to modern astronomy. And what these images show has absolutely blown everyone's minds. The directional structure that we're seeing in 3I/Atlas is unlike anything we've encountered before. Let me explain what that means. When astronomers talk about directional structure, they're referring to patterns in how material is distributed around or emanating from an object. With comets, for example, we typically see tails that point away from the sun, because solar radiation pushes gas and dust particles in that direction. It's predictable. It follows the laws of physics that we understand. But 3I/Atlas is showing us something completely different. The new images reveal that this interstellar visitor has a highly organized, almost geometric directional structure. We're talking about streams of material that appear to be flowing in very specific patterns, maintaining a consistent orientation over time. And here's the kicker. This structure doesn't seem to be responding to the sun's influence the way we would expect. It's as if 3I/Atlas is marching to the beat of its own drum, following rules that we don't yet understand. What makes this even more perplexing is that this directional structure has remained remarkably stable. Previous images taken weeks and months ago showed a similar pattern, and these new images confirm that yes, we're seeing the same thing. This isn't a fluke. This isn't an imaging artifact or a trick of the light. This is a real physical phenomenon that's happening with this object, and scientists are scrambling to figure out what could possibly explain it. Several theories are already being proposed, and each one is more fascinating than the last. Some researchers suggest that 3I/Atlas might have an unusual rotation pattern, something that causes material to be ejected in these specific directions. Perhaps the object is tumbling through space in a complex way that we haven't fully mapped yet, and this tumbling motion creates the patterns we're observing. Others are proposing that the composition of 3I/Atlas might be radically different from anything in our solar system. Maybe it's made of exotic ices or materials that sublimate in unusual ways. Maybe there are pockets of volatile compounds that are releasing gas jets from specific points on the object's surface, creating these directional streams we're seeing. And then there are the really wild theories, the ones that push the boundaries of conventional thinking. Some scientists are even speculating, very cautiously I should add, about the possibility that this could be some kind of artificial structure. Now, before anyone gets too excited or dismissive, let me be clear. There is absolutely no evidence to suggest that 3I/Atlas is anything other than a natural object. But the fact that serious scientists are even willing to entertain such possibilities shows just how unusual and puzzling this object truly is. What's particularly exciting about these new images is the level of detail they provide. We can now see features and structures that were previously hidden or unclear. There appear to be multiple streams or jets emanating from the object, each following a precise trajectory. The symmetry of these patterns is remarkable. In nature, we do see symmetry, but usually there's some randomness, some chaos mixed in. Here, the organization seems almost too perfect. The implications of understanding 3I/Atlas go far beyond just this one object. Now remember, this visitor came from interstellar space. It spent potentially millions or billions of years traveling through the galaxy before arriving here. What it can tell us about conditions in other star systems, about the formation of planetary systems, about the materials that exist throughout our galaxy, is invaluable. Every piece of data we gather from this object is like receiving a postcard from a distant part of the universe that we could never otherwise visit. The scientific community is now in overdrive. Observatories around the world are training their instruments on 3I/Atlas, trying to gather as much data as possible before it travels too far away. Time is of the essence here, because interstellar objects don't stick around. They're just passing through, and once they're gone forever. We have a limited window of opportunity to study this remarkable visitor. What happens next is anyone's guess. Will we figure out the mystery of the directional structure? Will new observations reveal even more surprising features? Or will 3I/Atlas leave our solar system with more questions than answers? One thing is certain. This object has reminded us just how much we still have to learn about the universe. Every time we think we have things figured out, nature throws us a curveball.